Hello friends, welcome to part 2 of Staad Pro. So in previous video we have seen how to design a Staad Pro from given coordinate values of the nodes. In today session we will learn how to put the dead load and live load on the node of the truss. Okay, so as I have already shown you in the previous session that calculation of dead load and live load. After calculating, I got these values. That is, on every node, the value of dead load will be 4.23 kilonewton, and on every node, the value of live load will be 6.08 kilonewton. It will vary accordingly. So let me put these dead load and live load and show you how to do the same. So first of all, as you can see, this is a 3D view. So let me convert it into the front view. So for that, go to view option and then select this front view option. Okay, so my truss is now in front view. Now, as we have already worked with the geometry menu, now we will go to properties. Under properties option, go to section database, double click, and then here a pop-up menu will appear. In this menu, we have to select the Indian standards. So search Indian and click on it. Suppose we are going to select a channel section, sorry, angle section. In this angle section, our angle dimensions will be ISA 6065. So search for 60 cross 60 cross 5. Yeah, here it is. And then type specification, let it be single section. And then material will be steel. Then click on add, click on close. Now, this is only added in this menu box. Till now, this option has not been assigned to this truss. So to assign this channel section to this truss, first of all, select the whole truss and then click on assign and then click on yes. Now, as you can see, here R1 is written. It means that all the members has been assigned with the channel section ISA 60 cross 60 cross 5 and material is steel. Now, we do not have to work upon materials and the specification section right now. If it would have been a beam, concrete beam, then we were doing with this specifications and materials tab. Now moving towards the support section. In support section, we have to provide pin support at both ends. Okay, so let us see how can we provide pin support. So first of all, click on this create button. Then you can find many types of support here. We have to provide pin support. So click on this pin support and then click add. Now the pin support has been added in this menu box only, not in the frame structure. So to add in frame structure, first of all, select this support and then you can use cursor to assign option, click on assign and then select that node on which you have to assign this pin support. Okay, so now as you can see, I am selecting the 0, 0, 0 node and then 7, 0, 0 node. In this manner, I have assigned this uh, pin support. Okay, now let's move to the loading part. In loading part, we have to create two new load profiles. How to create two new load profiles? For that, click on load case detail and then click on add. Okay, so under primary load option and loading type, click dead load and then write here in the title as dead load and then click on add. Similarly, we have to also create a load case for live load. So create here live load, then write live load, and then click on add. Now close this menu box. As you can see, dead load and live load case detail has been created. Now we have to assign the values of dead load and live load in this case details. So how we will do that? For that, click dead load and then click add. Then what are the forces we have to add in this truss? So we have to add for nodal forces, means the force will be point force and it will be acting on particular node. So we will be selecting nodal load from here, and then as we can see, the value of nodal load is 4.23 kilonewton for dead load. So just put 4.23 kilonewton with minus sign. I hope you know why are we putting minus sign here. Minus 4.23, okay, kilonewton. And then now click on add and click on close. As you can see, a sign of question mark here. Question mark means this load case detail has not been assigned yet to this truss. If we will assign this load case to this truss, then question mark will change. We will see later. Okay. Now let me first of all put the value of live load here. For that, select the live load, then click on add, then go to nodal load. Nodal load because these all force will act on the node. Therefore, it is a nodal load. The value of nodal load will be 6.08 kilonewton for live load. So putting 6.08 kilonewton with minus sign, click on add, then click on close. Okay, now let us see how we will assign these loads to the nodes. For that, I am first of all going to select this load, then click on use cursor to assign, then click on assign, and further select the nodes where you have to apply these load. Okay, so this is the node, this is the node, this is the node, this, this. And one thing which I have forgotten here, that at the end nodes, the value of load is p by 2. So I have to create one more load case detail with loading p by 2. That is, the load will be 4.23 divided by 2. It means the load will be approximately 2.1 kilonewton. So let me create a new load case. For that, again go to dead load, then click on add, click on nodal load, put minus 2.10, then click on add, then click on close. And now I am going to assign this minus 2.1 kilonewton to this end nodes. For that, select this minus 2.1 kilonewton, then go to use cursor to assign, select this option, then click on assign and further select the nodes. You can see there are two color of loadings. One is purple and other one is green. Purple means this is currently selected or this is active load, whereas green load is deselected load or not an active load. Okay, so let me also create the nodal load for end nodes in live load case detail. Yeah, one thing more, as you can see, the question mark has been changed to some green color thing. Okay, this means the load has successfully been assigned to the truss. Now let me create another load case for live load, that will be p by 2 and value will be 3.04. Then first of all select the live load, then select add, then go to nodal load and select value of minus 3.04, click on add, click on close. Now by this time you cannot see any load on the nodes. So if you want to see, then click on dead load and click on the value of load. So you can see the arrows right now. Now let me assign these live loads on this truss member. It has not been assigned right now because the question mark, as you can see here. So first of all, let me select this load, then click on use cursor to assign, then click on assign, and further assign this load to these all nodes. Okay, now again click on minus 3.04 kilonewton load, then click on use cursor to assign, then click on assign. Again now click on this minus 3.04 kilonewton load, use cursor to assign, then click on assign and assign these loads. Okay, now if you want to change the scale of this load, it might be possible that you are getting big arrows in your StatPro software. So to change the scale of the loads, simply right click, then go to labels. In label option, then go to scales, and under scale, this is point force, so we will change the scale of point force. Suppose I am changing this, then click on apply. So you can see the nodal loads pointer has increased. So to decrease the size, just increase this value and then click on apply. In this manner, you can change the scale and click on OK. So after applying all the loading, let us move to the final command, that is analysis command. Under analysis command, go to define command, then under perform analysis and no print, click add, then click close, and finally click on run analysis. Click on save. Okay, so in this manner, we have run the analysis. Then further close this. Now after that, since we have to find the value of tension and compression values, so we have to add it. For that, go to post analysis command and then again go to define command, and under analysis print command, go to member forces because we have to find the member forces, and click on add, then click on close. Now as you can see, here is a question mark. It means that this command has not been assigned to this truss. For that, first of all, select this complete truss, then click on assign to selected beams, then click on assign, then click on yes. Now this command has been successfully assigned to the given truss structure. After that, go to run analysis and select view output file. Click on done. Okay, let us ignore the warnings for a period of time. And then as you can scroll downward, you can get the values of uh, axial tension or compression in members. So as you can see here, this is written, this is member 1. Member 1 is between joint 1 to 9. So joint 1 to 9, and it is experiencing uh, force of 33.24 kilonewton in the global x direction at node 1 and in negative global x direction at node 9. So in this manner, you can get the member forces in all the member of the truss. So this was our aim, our objective, and we have completed it. Thank you for your attention.